Hello everyone, my name is Paranjay Sharma. I am a student at IIPS DAVV. I am currently in my 5th sem of MCA. This is a video regarding my assignment for the subject Introduction to Data Science. This is a playlist which I am making for particularly end semester examination questions and solutions which were given to us by our professor Dr. Shaligram sir. Now let's start with the first question. With the first questions B part. We have covered A part in the previous video. So the first questions B part is basically differentiating between structured, unstructured, quantitative, categorical data with real world examples. So let's start with the solution. So structured data is basically the data which we can have in rows and columns. Unstructured data do not have any predefined consistent structure. So basic examples are SQL databases, emails and videos respectively for both. Its searchability, it's highly queried using algorithms using SQL, the structured data, and unstructured data requires processing like NLP, computer vision to extract meaning. Structured data do have a linear growth, and unstructured data they have an exponential growth. As we can see in the previous years, it's 20% and 80% respectively. Then we have statistical types, which are these were the organization types. Now we are coming to the statistical types. So the statistical type, quantitative versus categorical data. In quantitative data, we have discrete and continuous values. Discrete values like 1, 2, 5, continuous like 98.6, $99.9, etc. And in categorical or qualitative data, we can say we have values like nominal and ordinal, like colors, red, blue, gender, male, female. In ordinal, we have ratings like low, medium, high, and more than just a clear order, right? It's a label with a clear order is called ordinal, and label with no order is called nominal. Then coming on to the next question, which is question number 2, part A. In this we have to demonstrate the algorithm using naive Bayes theorem and use a small world example, real world example, to showcase the model. So the mathematical foundation, the Bayes theorem says that probability A given B is equal to probability B given A into probability of A divided by probability of B, which is nothing, it's just a mathematical formula. We will understand it using an example below. So for example, this is our data set. The probability we have the data of email which is spam and not spam, okay, which is represented as S and NS respectively. So probability of the mail being spam is 0.4 and the mail not being spam is 0.6. Then we calculate offer. There is an also third piece which is based on the presence of the word offer, right? If we have offer in our email, it may be spam or not spam. So we calculate the likelihood using conditional probability, that is probability of offer given that the mail is spam, it's 0.80, and likelihood of likelihood, that is the probability of offer given that the mail is not spam, is 0.1. So we calculate the numerator, which is probability of A given B into probability of B. This is for the spam path, and not spam path we do similarly probability of A into B. which will give us these values, and we then divided it by probability of uh, uh, then in step 3 we normalize using the Bayes formula, which is probability of a given b, which will be equal to 0.32 divided by the sum of these two, which will give us the percentage. So result, even though spam is less common, that is 40%, the presence of the word offer increases the probability to 84.2%. Moving on to the next part, that is the B part of the question number second, we will discuss about the binomial distribution, the normal and the Poisson distribution. Binomial distribution lies under the discrete category. There are two categories of distribution, discrete and continuous. It lies under the discrete category. Its CDF is represented by this formula. So there are assumptions and applications of it as well. The assumptions are it consists of a fixed number of trials. It has a binary outcome. The outcome of one trial is independent of the other trial. It has a constant probability of success, P, which is P over here. We can use it in various applications like quality control, clinical trials, survey sampling, etc. The Poisson distribution is the second type of distribution that we are going to talk about, and it also falls under the discrete distribution category. Its CDF is represented as in this formula. Assumptions made, similarly events occur independently, like in binomial distribution. There is a constant rate at which the event occur, which is represented as lambda, and there is non simultaneousness, which is that two events cannot occur at the same given instant. Its applications are traffic engineering, reliability, operations tracking, number of calls received by a call center per minute, etc. So it's a basic simulation for this, and for this as well we have a basic simulation. We can change the probability as well. The normal distribution, it lies under the continuous distribution category. The assumptions made are the data is continuous. The distribution is perfectly symmetrical around its center, which is found rarely. We also call this normal distribution as Gaussian distribution, and the parameters which we use are mean and standard deviation. The applications of this are biometrics. We use this in height, weight, blood pressure. In finance, daily returns of stocks are often assumed normal, though they are not. Measurement error, random errors in scientific instrument usually follow a normal pattern. Coming to the thank you for watching the video. Stay tuned for the next video.